I think that's true. Yeah, it weighs exactly. It looks like
I don't know. That's amazing. So I have 10 examples for you today. And again, I'm sorry in advance, but if you struggle with this lesson today, it won't be because you're struggling with the lesson today. It'll be because you're still struggling with the things from the past. So you'll want to take some notes here, I think. I would. I don't know about you. But today is February 1st, yeah. And we are going to be adding and subtracting radicals. And I shouldn't even say radicals, I'm going to, but these specifically today, they are a specific type of radical. They're the only type of radical that we've talked about yet in this class, and they're called square roots. So we haven't really talked about cube roots or any of that. I don't know necessarily that we will, but we probably will. So for us, we're adding and subtracting square roots here today. Sound good? So my first three examples are not meant to insult your intelligence. They're merely meant to point out kind of mechanically how this works. Is homeboy looking for notes over there? Is that what is he digging? Okay. Wasn't sure. I thought maybe he was having a nightmare or something. So the idea is that radicals are like variables in that they determine whether or not terms are like terms. And so if I gave you this, if I gave you like 5 roots of 2, and I asked you to add to that 6 roots of 3, you would hopefully look at me once you know like what's up and say, you'd say, I can't do this problem. And the reason why you can't do this problem is because it's like saying 5x plus 6y. You know, just like we've always learned how you can't put x's and y's, you can't add unlike terms, the same goes for roots. You cannot. Just in the same way that if I gave you 5x and 6y, you can't just pick the 5 and the 6. So if I gave you 5x plus 6y, and said simplify that, I would expect you to look at me and say, it's already done. And if I gave you 5 root 2 plus 6 root 3, I would expect you to look at me and say, it's already done. Okay, so let's be clear about that. Chance? The numbers on the outside don't matter. So let me give you another example of that. So imagine that I switched this now to say like 5x plus 3x. And don't let yourself get confused. You and I both know that the answer is 8x, right? Because if I have 5 x's and someone gives me 3 more x's, I'm like, hey, I can put those together and say I now have 8 x's. So I don't really give a rip about the numbers outside. The issue is, are the numbers, the x's, are they the same? So like in that same vein, if I gave you, let me write this in red here, if I gave you like 5 roots of 2 plus 6 roots of 2, now you can do this problem. You think of a root of 2 as like a physical object. Like if Kale has 5 roots of 2 and Rocky gives him 6 more roots of 2, he has 11 roots of 2. Right, and actually it being a dead root is pretty important, because if it's not a dead root, then we're probably going to break them down anyways. But I'm just trying to get you warmed up with this part, just to make sure you guys are clear. You can, of course, yeah. So like for an example of that, if I gave you like 6 roots of 10 and I asked you to subtract 11 roots of 10, you look at those, and job 1 for these first 5 minutes of the lesson is to get you to say, okay, those are like terms, right? And so, yes, you can go negative. It's, again, it's no different. This math question is no different than if I said, what is 6m minus 11m? Like if you have 6m's and you take away 11m's, you have negative 5m's, right? And in the exact same vein, the answer to this problem right below this white line is negative 5 roots of 10. Okay with that? And you might wonder about the root of 10. Can we break him down? Not in any meaningful way, right? 10 is one of those numbers that like you could break it into 2 and 5, but you wouldn't because neither one of them is progress, right? What were you gonna say?
So if they're like.
Uh-huh. Uh-huh. Right.
What if it's on top? That's just the final answer. It can be broken down, so that it can-
Yeah, so like this would be a final answer. In the same way that this would be a final answer, but in this case, this is a final answer.
So, but why wouldn't? You know,
Because when you have physical objects, so you're asking a really good question here. When you have physical objects, you can only combine them together if they're the same type of objects. And so like if you had, you know, 4 cookies and someone gave you 3 oranges, I'm sorry that this is really a dumb answer, but I'm just reaching here. Like you can't make the case that you have 7 cookie oranges. Do you know what I'm saying? Like it doesn't make sense. So like by the same logic, if you had like 5 X's and someone tried to give you 3 Y's, you can't say you have 8 XY's. So, but again, so I think what I'm trying to say is the objects themselves don't change. It's how many of them that changes. That's always been the case with algebra. So like if you had 3K and I added to it 10K, you just have 13 Ks, right? Like there's still Ks, but you just have more of them. And so we have to think of roots the same way. So if I had 10 roots of 5 and you took away 4 of my roots of 5, I still have some roots of 5, but I only have 6 of them. I'm going to keep saying this. It's not the objects themselves that change. Okay, it's just, huh?
How come like the root five?
Wow. So I really need you not looking at your Chromebook. Okay. I want you to pay attention and listen to me carefully. Yeah, seriously, like shut those things. You don't need those right now. What changes is how many of the objects that we have. I could do 20 examples of this, and I don't think that anybody wants me to. But if you had 10 coins and you took away 4 coins, I was going to call them dimes, but someone's going to make a freaking drug joke or something. And so, I mean, just coins. So if you have 10 coins and you take away 4 coins, what do you have? So your answer, I mean, you're answering your own question. If I ask you this question, why didn't the coins change? Because you just have less of them, right? If you have 8 tacos and you purchase 2 more tacos,
Root 5 is the number.
stop it. It's a thing. It's a thing. And that's what the point I'm trying to make is root 5 is no different than a taco. Roll with me here. If you have 8 tacos and you walk up to the stand and you order 2 more tacos, what do you have? You have 10 tacos. They don't change into double tacos or anything like that. You have 8 tacos, you buy 2 tacos, you now have 10 tacos. I didn't mean to be short. I already kind of explained this, and I think you were staring at your Chromebook. So
No, I heard you. I just didn't understand.
what changes is not what we have, but how many of them we have. Clear? And yes, I get that root 5 is a number. If I gave you 8 root 5s and then you purchased 2 more root 5s, imagine there's a thing on a shelf at Walmart called a root 5. It's the root 5. They sell it for $13.99. It's a little thing you stick it in your pocket and it, holds your earbuds or something. You're like, oh man, I got this new root 5. It's really cool. If you have 8 of them and you buy 2 more of them, you have 10 of them. Clear? They don't change.
No change. I'll let you.
Thank you. They don't change. Only the number of them that we have changes. Boy, that was supposed to be a 3-minute introductory part, and boy, did we make that into a mountain. Let's move on. Okay, so having said that, let's take a look at this. I guess maybe I should just so I can sleep tonight. Let's make sure that we're all okay. First off, can we do this problem?
Yeah.
Yes, we can, because the root 5s are the same. And it is going to be negative 14.
Room 5.
Right. We clear? Hopefully clearer than mud. Let's take a look now at this. So this is where the actual lesson for the day is supposed to start. Can we do this problem? No, but yes. So this is really the meat and potatoes of what we're doing today. And this is, I warned you about this, that if you struggle with simplifying roots, you're going to struggle all day today and tomorrow. So on the surface, I look at these and I say, I can't put you guys together because my teacher, that stubborn guy, told me that I can't put root 8s and root 18s together. However, buried somewhere under the pile might just be some like terms that I could find. So what I'm going to do right now is I'm going to take the square root of 8 and I'm going to break it down into 2 different square roots. And then I'm going to take the square root of 18 and I'm going to break it down just like we've been practicing for literally over a week now. So if I ask you to break down the square root of 8, it would break into a root of 4 and a root of 2. I always put the one that's better first. Good. Thank you for asking, Kale. Yes, always put the one that you intend to root first, and then your answer kind of keeps in the same order as you go. So the red stuff that I'm writing is going to become 2 root 2. Now, with a little bit of color coding here, I'm going to draw your attention to something. This negative 3, you've seen this before, is a previous jailbreak. He's going to multiply by his homie 2 to make, very good, Colby, negative 6 roots of 2. Okay. Now let's press on over on the right-hand side and work with the yellow stuff. What 2 numbers would 18 break into? Definitely a 9 and a 2. I just like to go slow, and then it will become, yes, a 3 root 2. And yet again, follow the green boxes. Previous jailbreak of positive 5 multiplies by new jailbreak of 3, resulting in 15 roots of 2. And then you look at it and you're like, what the what? So now we look at the problem and say, I got this. We get 9 roots of 2. A problem that we couldn't do initially becomes doable by breaking the roots down to expose the pieces that are within. And you get your answer. Right. All right, let's try another one.
This is it.
This is what we're doing today. Yep, there's no next. The numbers will get a little bigger, but this is what we're doing. Yep. So let's do 6 root 6 minus 10 root 24. So, I mean, you're on to me now. You know that the answer, if I said, can we do this, is, well, no, but yes. So what are we thinking for progress here?
6 into 3 root 2.
Can I break a root 6? I cannot. So remember that even though a number can be broken, you only break it if it's got a purpose, and 3 and 2 are trash. But I am going to go play with the 24. Very good. So the 6 is like, I'll just wait here while you go do your thing.
Now here, it'll be negative 10 times 2.
Correct. You got it, bud. So this side becomes 2 root 6. And then I'm going to use a little bit of, I'm going to be a little more careful with my boxing this time. The jailbreak previously was negative 10. I'm going to circle that negative this time because that's pretty important. And multiplied by 2, it becomes minus 20. So what the problem really looks like now is 6 roots of 6 minus 20 roots of 6. And yet again, you go, there it is. Found you. Got you. What is 6 minus 20?
14 roots of 6.
So far, so good?
Yeah.
So you can see what I mean. Like if you suck at breaking down a square root, that's just going to be adding frustration to your already big fire, right? So make sure if you're not good at this yet, use again today to practice. How about this one? I conjured up a bunch of these before you got here, so I'm trying to find some that I thought were good. So can the roots be broken? Yeah, and in fact, in this time, they both can. So I'm going to play with the 50.
25.
Good job. Thanks, guys. 25 and 2. That's what I'm looking for, is always those before we root them numbers. And what's the root of 25?
But,
And so what is my entire left side ready to be?
oh, no, 20 root two.
20 root 2. And again, Kale, you got to multiply the 4 that was already jailbroken by the 5. Right. Okay. And on the other side, I'll use my yellow now. How do you break down a 200? Very good, Sam. 100 and 2. That's the best combo for anything that ends in the word 100. 700, 500, whatever. Always use that 100. Get them out of there. And what is the square root of 100? Yeah. So what's going to come after 20 root 2? Good job. So again, negative 40 root 2. You got it. Neat, huh?
Could you, is there such thing as timesing and dividing these guys?
Yeah, not today. We're not gonna, like, dividing is really more of what we've already kind of learned with that. Remember the ones you've been doing, assignment 1, where you multiply the top and the bottom?
Oh, yeah.
And multiplying is pretty easy too. It'll be on Daddy Delt. Let me knock like maybe 2 more examples and you guys are good. Okay, so stick with me here for a couple more, please. It is. And there's certain numbers that no matter how many times I put them on the board, my heart goes out to you. You're going to want to say 6 and 8. You're going to want to say 4 and 12. You're going to want to say all these things. And like Sam has figured out, you have to train into yourself those death numbers. I remember Miss Willoughby, she wrote us, I think she even wrote us on the cheat sheet, one of them, she actually wrote like death numbers, right? And these are the numbers months ago that I cautioned you. 48 is one of them. 32 is one of them. 80 is one of them. Anything that is 16 is going to be, we're going to miss it. So thank you, Sam, on that. So when we break down a 48, we got to train ourselves to think of 16 and 3. 8 and 6 is trash. 4 and 12 is trash. Right. And so what does that red part become? Good job. So the entire left side becomes what?
Negative 28.
Negative 28 roots of 3. Good job. So left side is done. And let's head on to the right side. How do you break down 75 cents? If I had 75 cents in my pocket, what do I likely have?
3/4.
I more than likely have 3/4. Quarter math is my favorite. Yeah. If you can make it with quarters are the best because they're 25 times something. And 25 is rad because it's rootable. So the entire right side becomes what?
40, 43,
Good job.
20, 12.
Nice job. Now I just want to do one more example where only one of the roots has to change, because I feel like that would be something that we might see in the assignment and say, like, I'm freaking out here. So here's another example. So you would have picked this up from an example about 5 minutes ago, but not every problem do you have to mess with both roots. Like one of the roots might already be dead and waiting hopefully for a mate. So like the root 11 in this case is like, I got nothing to give you. Hopefully you can pry another root 11 out of someplace else for me to go to the prom with. Right. So we're going to take that root 44 and we're going to bust it down into 4 and 11, making 2 root 11. Very good. Which eventually makes negative 4 root 11. And then the 5 root 11 is like, hey, thank you. So it's just root 11. So the goal is to make the roots the same, right, in a nutshell. You guys have any questions? Right on. That started a little rough, but I felt like we smoked it at the end, so good job. Much better. Yeah, it's on Daddy Delt.